We read the instructions starting on page 28. We're looking at 15 to 23. We just want to restate this using the distributive property. Okay, so can somebody help me restate it? I don't want to know what that final value is because it said do not simplify, but I want a restatement. All right, John?
Is it 3 times 11 and then 3 times 12?
Yeah, it's going to be 3 times 11 plus 3 times 12. All right, the pattern you're seeing here is that this outside number gets multiplied by the first number being added, and it gets multiplied by the second number being added in the parenthesis. Do you guys see that pattern? Okay, so whether this was a variable or a bigger number or a variable and a number, it's the same pattern. It's that multiplying by both of those inside. This would be your restatement. This is your answer to number 15. That's it. And I think those are the ones that were clearly explained yesterday, so I think you guys got this. I hope. All right, number 16, this is where we start getting into, like, all right, what are the other varieties of these problems? All right, number 16. This one is 5 plus 7. 5 plus 7, and then an x on the right. This one confuses a lot of people because, hey, Mr. A, how do you get the distributive property going here? That x is over here on the right. Okay, what property can change the way this looks so that it's easier to deal with, maybe for some of you who look at that and say, what do I even do? Tristan? Commutative. Commutative. All right, listen up, guys. What's happening between this number, I don't know what it is, but this number and this sum? What operation is going on? Yep. Multiplication. Now, when you have two factors, can you switch the order?
Yes.
Okay, so watch what I do here. I'm going to rewrite this way. Is that allowed? Okay. Now that we see it this way, which you can do, you can manipulate that to help it maybe to be clear to you. Now you do what you did on the top one. So, Bella, did you want to help me out with that?
I was going to say
go ahead.
You
You do not have to do that. I'll show you both ways, I guess.
But I can help.
Go ahead. Thank you.
So you write out to wherever you want to put it. You put the 5 in parentheses, and x, and then you add the addition mark, and then you have the x, and parentheses, and so.
All right, how many of you can see from here to here? Like you can see that. It's the same pattern. Remember, we took the number outside, multiplied by the 5 and by the 7, and it's being added. Same pattern? Okay, let's say, and actually this is good that we brought this up. You're like, I don't know that commutative property. So what do I do when it's like this? You could still do the distributive property. A number is outside the parentheses, and something's being added in the parentheses, so I can just do this. Multiply by the first number, multiply by the second number. And so what would I get? What's x times 5? Well, it's just x times 5. And then x times 7. You should still be able to get the same answer. Okay? But if you want to make it clear for yourself, use that commutative property. Do we like commutative property?
Yeah.
Yes, I like it. Because sometimes it just makes it easier to look at. Okay. Any questions on 16? Let's go to 17. Okay, I'm going to have to add a page. All right, 17. This one is 6t plus 11t. Okay, do we have parentheses here?
No.
No, so we're going to have to work in reverse. Remember these other two examples, the ones we did before? They had parentheses and a number outside. This is what we came up with. Well, this example we have now is almost like you did this. Right? Wait, I thought that's what we had to do on the other two. Yeah? Now we have to work backwards. So that's not the answer right there. That is not the answer. You got to restate it. You got to rewrite it. Okay. Well, I'm going to rewrite it here just so you can see what I'm doing. All right. How many terms here? 2. Is there anything that both of these terms have in common? Tristan.
The same letter.
They have the same variable, right? They both have t, so 6t, 11t. Do you guys remember what I could do with that to write it with distributive property? They both have a t in common. So do you remember what can come out? What can be factored out and put outside the parentheses? Jensen?
You can combine a t, right?
Technically, like if you want to simplify, boom, you can combine them. But do you remember how I use it? Use distributive property to show that? John?
Can't you put the t outside the parentheses?
Okay.
The 6 plus 11 inside?
Do you guys remember that a little bit? It's okay. Don't feel bad if it's not like second nature yet. If it's not, it's okay. We're going to go through many problems. We're only on 17. But does everyone see here? We had our two terms. They both have a t in it. So technically what we're doing is we're factoring out a t, and then we're still left with the 6 plus 11. If you're like, what did you just do? This is not the same thing as what they gave us. Think about it. What is t times 6?
16.
And what's t times 11?
11.
So are these two actually the same? Okay, this is just rewritten. It's written in a different way to show distributive property. Okay. 18. They up the intensity here. 18. This is where it gets tough. 2a plus 4b. 2a plus 4b. Okay, we kind of talked about this since we were grading, but doesn't it look like these, how many terms? These two terms are not like terms. Why are they not like terms? They're not, and why not? Rosa?
Because they don't have the same variable or number.
Yeah, and we would say the reason they're not like terms is because they don't have the same variable. This one has an A, that one has a B. So with the variables, can you take anything out? Like, can you factor it out like you did up here? No. But there's something else, guys, and I need you to focus here because I want to help you out. There is something that can come out. They do have something in common. What's being multiplied here?
2 times a.
2 times A. What's being multiplied here? 4 times B. Can't I say 4 is really 2 times 2? Okay, so watch what I'm going to do here. I'm going to rewrite this. 2 times A, and then I'm going to write here 2 times 2 times B. Is that allowed?
Yes.
Okay. Do these terms have something in common now? Max?
They're two the same number and each.
They have a same factor, don't they? What's that factor? Okay, what's the same factor they have? This one has a 2 and an A, that one has a 2 and a B. What's the common factor that they have? What's the common factor, Caroline?
2.
They both have a 2, okay? And you can pick either 2 there and that 2 right there. All right, if they both have a common factor, I'll get to you, Bella, in just a moment. If they have a common factor, I can factor that out of the expression. So watch what I'm going to do here. I'm going to take both of these and put them out here in the parentheses. They're common. What was left here in this first term? A. What was left here in the second term? 2 times B. And it's adding? That's distributive property right there. Yeah, and don't worry. So far we've had what, like 4 different problems? Like varieties? That's okay. I'll show you how it keeps going. Yes, ma'am. Oh, sorry. Let's go. I'll get you, Belle. Elizabeth, go ahead.
For the homework,
Mhm.
I put 8, and then I put A plus B in parentheses.
8 outside,
Yeah,
like.
I multiplied 2 times 4, and then I put the A plus B in parentheses.
Yeah, and so I see what you're doing there, but that changed, so that 8 and then the A plus B inside, that would be 8A plus 8B, which is different from the original expression. You see what I'm saying? But that's a good thought process. You can always check yourself. Ma'am?
Why couldn't we just do 2 and then times A plus 4B?
Okay, if you, let's say you have the 2 here, the A, and then you put 4 here. Is that what you're saying? The only difference is the 4. What happens? Well, you're still going to get 2A, and that's good. But what's 2 times 4B? 8B. So it changes the problem. Yes, sir?
What happened to the other two? We're on the 2 times 2 times b.
Great question. What happened to this guy? Or that guy, whichever you want to talk
The
about.
one that's not underlined.
Remember, if I rewrite this right here, wouldn't I do 2 times a? And that would give me 2a. And then I would do 2 times 2b. And what would that give me? Yeah. Or you could say 2 times 2b is 2 times 2 times b. Yeah, so it works its way up. Yes, ma'am. Wow. Swivl and I apologize,
My question
y'all.
was before the answer came.
Uh-huh.
Can't you just write that one as an exponent and just put a 2 there instead
Like
of
a 2 squared?
Yeah.
Like right here?
Yeah.
Yeah.
Yeah. Can't you just put that if you're working it out?
You could, and that's like right here, instead of putting 2 times 2 times b, you put 2 squared times b.
Yeah, it was getting on me.
And no, it's a good question. You could do that. Totally okay. As long as when you take away one of the 2's, that you're left with only 1 2. So that's okay. That's totally fine. Okay. How many of you feel a little bit better from last night? Just a little bit. Not like, oh, I can do all these in my head now. A little bit better? Okay, let's keep working. Number 19. All right. Number 19, 2r plus 12s. 2r plus 12s. Okay. How many terms, everyone? Everyone should know how many terms by now, I hope. How many terms? 2. We're good with that? And so I just underline them so I know, okay, those are the numbers I'm talking about. Are they like terms, though? No, because they don't have the same variable. So am I going to pull out the variable? No. But is there something I can pull out? Let's see here. Brayden, what do you think?
Could you do 6 times 2?
Over here? Yeah.
Because there's a 2.
So let's see here.
Could you do 1 times 2?
Can you say,
Instead of doing the 12, can you do...
sorry, that was from another class.
Instead of doing the 12, can't you break down the 2 instead of...
So this 12, when I write it like this, still has to be worth 12. Like, are you saying, can I break it down to 1 and 2?
No. For the 2, can you break that down to 1 and 2 instead of breaking it down to 12?
Okay, I see what you're saying. This 2,
Yeah.
break it down to 1 times 2. You could, like this,
Yeah.
but it doesn't add anything to what you're trying to do. It just maybe adds another number, and that's that identity property. Everything can be multiplied by 1 and not, and in this case, it wouldn't help you, unfortunately. But yeah, good questions here. Okay, so what's the common factor between this and this? Let's see, Mackenzie, what's the common factor between this term and that term? 2. That goes outside the parentheses. That's the common factor. And actually, you know what? I'm glad we're doing this because I'm giving you terms factoring and common factor. Super important. What's left behind in the first term? R. What's left behind in the second term? 6 times s. And what's going on between these two? Addition. That's the answer.
And I'm ready, Kristen, for dismissal.
Yeah. Oh, yes. Tristan, I'm updating Sycamore, so no quiz tomorrow. It's on Wednesday. I said Wednesday. I'm going to get problems from this assignment, but I haven't put them on Sycamore. So, and honestly, I haven't even thought of them yet. All right. So I'll get that update on Sycamore. Okay. Do you guys see how I got this right here?
Yes.
You guys see it a little bit more? How many of you feel more comfortable with this answer than you did with that first one? How many of you do not feel comfortable with these? Okay, stay with me here and I'll help you out. Ask me questions. Number 20. Number 20. All right, here we go. 6. And Tristan, if you don't mind exiting from here, thank you. 6x plus 6y. 6x plus 6y plus 1. That's number 20. Okay. How many terms are in this one? terms. Okay, ready? First term, second term, third term. Remember what separates terms again? Addition. Addition or subtraction. And here we have those addition signs. You okay that it's 3 terms? So far, so good? Okay. I'm looking at these, I'm thinking, I don't like that one. So if you guys are paying attention, it'll help you out. I don't like that one, but it is added to this problem. Looking at these 3 terms, are they like terms? Are they like terms? Raise your hand. They are like terms. Okay. Raise your hand. They're not like terms.
They're not.
Raise your hand if you didn't vote. Thank you. These are not like terms. Remember, what's the definition of a like term? They have to have the same variable. So does this have the same variable as that or that? No. Variable. None of them have the same variable. We're good so far? Okay. What you want to do is realize, does anyone see which 2 terms I can use distributive property on? You want to try, Michael? Which both?
6x and 6y.
These 2 right here can be rewritten with distributive property. Okay, watch. Let's focus on these 2 for now. Ready? What's the common factor of those first 2? Raise your hand. Don't just blur it out. Josie? 3 is a common factor. What's another common factor? You're right. You're right so far. Jensen? 2. They're both right. What's the greatest common factor between the 2? The GCF. You've learned that. Marissa?
2, 3.
That's okay. If your choices are 2, 3, or another one.
I have
Callie?
6.
6. Isn't that the GCF? You see it? So you were right. You were right. And the greatest common factor is going to be 2 and 3 combined. So if the GCF of these 2 is 6, that can come out. Right? The 6 can come out. What's left behind? Okay, hold on. Don't say it. Elizabeth, what do you think's left behind?
The X.
The X. Mackenzie, what do you think is left behind on this one?
The Y.
And what's going on between these 2? Jack. P. Addition. That's what I have so far, don't I? Okay, what about that lonesome one? He's just there. Just by himself. And you're done. He's done. Sometimes you can't pull anything out of... I mean, you could technically say that the GCF of the 3 terms is 1, right? But that doesn't help you out. Yep.
Why would you put the 1 inside of the
Good question. All right. Why can't I put those parentheses up there? Let's say we did that, and I'll use a different pen. Let's say we did this. 6 times x, 6x. That's good. 6 times y, 6y. That's still good. What about 6 times 1? So wouldn't that change the original problem? So it wouldn't work to have that. Oh, it wouldn't work to have that change the parentheses over here. It only works right here in this problem. Okay, that's a tough one. Whew. You know what? I think you guys, not that you fully get it, but some of you are getting it, in the process of getting it. Okay, so what I want you to do is work on number 22 on your own. You're doing it on your own. 22. Skip 21 for now. Do 22. I'm rooting for you right now. I'm like, please get it. Please think it through. You can do it.
I had to ask 8th graders yesterday.
That's okay. That's all right. It's good that you're asking people, but let's see if you guys can get it on your own. You have it already? Okay, hold off on that. If you have it, just wait. I might call on you for the answer. So 22. Okay, remember guys, if that's distracting, we probably shouldn't reciprocate that distraction because now we're all distracted.
You should tell them, and then they should get in trouble.
Okay, question?
Have you ever had to go over there and be quiet?
Not this year. Yes.
Not yet.
Okay, hold off on the answer. Does anyone have a question up to this point? What to do? Okay. Who has an answer? I'm not saying it's the right one, but who has an answer? Okay, who needs more time? Okay, yeah, go. Take the time. You're good. I'm going to have the person who gives me the answer explain what happened. What did you do? And how? And I'm going to have someone else explain how do you know your answer is right. Okay. Let's go with Sydney. What is your answer?
My answer is 12, and then parentheses R plus
I just have a question.
Just a moment. Yeah, good job. Good job, Sydney. How many of you got that? How many of you got that? Okay, good. Now listen to me carefully. What you did is you identified there are two terms. And then you realize, okay, they're not like terms, but what is the GCF of the two terms, right? And the GCF of the two terms must have been 12. But then what was left behind? And now, somebody else tell me how I know my answer is right. So I got my answer. Hey, we all cheered, but I don't know if it's right or not. I'm just kind of hoping it is. I really hope it is. All right, Elizabeth?
Well, if it was an odd number, you can check in the back of the book. Or, because it isn't an odd number.
Bummer.
If you look back to 15 and 16 and problems like those, you can see that if you have a number and then the two numbers in parentheses, then you can use the distributive property to multiply 12 times R and 12 times S.
Okay, you can check yourself going the other way. 12 times R is? 12R. 12 times S is?
12S.
And they're being added? Added. We're good? Another way? Yeah, go ahead.
Couldn't you put something inside it so you can say R is 1 and S is 1 and then write it out?
Yeah, okay, great, John. I totally missed out what you said. Why don't you pick values for R and S? Pick any numbers. You could do like 1 and 2. Nothing too big. Oh, great. Actually, you know what? Let's do that right now, John. That's a great suggestion. All right, listen. R is going to equal 1. And S is going to equal 2. All right, make it nice and easy. You can do different numbers. You don't have to. Ready? All right, this is the original problem. What's 12 times 1? 12 times 1 is 12. What's 12 times 2?
24.
What's 24 plus 12? 36. So if this problem had these values substituted, this would be 36, right? I'll write a 36 here just so we keep track of what we have. Now, is it going to work here? I really hope so. What's 1 plus 2?
3.
3 times 12?
36.
You checked it. You got it. It has to be right. Works on all of them.
Oh, that's what
All of them. Yeah, so you can pick values, pick low ones, so you don't have to go too high. Yes, ma'am.
Are
Bella.
we ever going to get to do that?
To check them?
No, are
Or-
we ever going to get to simplify them?
Yeah, oh yeah, yeah. The next problems are going to be simplify the expression. Yeah, we'll get there. Yeah. Yes, ma'am?
Can I get some water? No.
Go.
Do not hydrate your brain.
All right, you guys seem to be good at this, but let's go back to 21. So you guys were asking, what about 21? Yeah, I don't know. We skipped it. Now I want you to do it on your own. I want you to rewrite it using distributive property. This one is 9
Easy.
plus 8 times. All right, if you're talking without permission, what you're telling me is that I don't get enough homework, this is too easy, Mr. A, and I can help you with that. Okay, I'll give you a few more moments if you have the answer, just a moment. And then I'll have Caroline give me the answer in just a moment. So if you need time, you can go ahead and do it. Okay, go ahead. Caroline?
Okay. Well, do you want me to work through it or just like?
Just tell me what you got.
Okay. I got B, and then parentheses 9 plus B.
How many of you got something like that? You may have put 9 times V or 8 times V, still using the commutative property. That's okay. How many of you got an answer that's correct? Look at that.
Everyone?
I'm pretty sure. Okay, ready, guys? Ready? Yes, ma'am. Go ahead.
Can you do 9 to say in parentheses then?
Like, that's what they gave you.
Oh.
So see, and no. This is it. They give you that, so you're like, they want me to rewrite it, so it has to look different.
Yeah,
Which
I
is,
understand that. I didn't see it.
that's okay. But yeah, you could go backwards and you would get that.
I got the answer right.
Good. That's all right. All right, ready, guys? This is your like test to see if you really get it. Number 23. Rewrite it. If you get this one right, I think you're good. All right. So who needs more homework?
Oh, homework? No.
Yeah. Yes. Question? Need more? Oh. It's an emergency. Thank you. Maybe you can wait a few minutes. Look at that. Okay. So 23.
I'm so confused on that.
Okay, let's see. Marissa, do you have an answer? Not yet? You're just rewriting it.
I think I know.
You're rewriting it. Jack up here, do you have it?
I did not.
Do not? It's okay. Let's see if we can get it.
Wait, is it an odd
Hold on. Don't say it. Remember, if you're not raising your hand and just talking out, or I haven't called on you, and you have your hand up. Callie? Elizabeth? Wait, do you have an answer?
I think so.
Okay, and then if you don't, I'll check with Jensen. All right, go ahead.
Is it 2 with 4x in parentheses plus 2 plus 9y?
Yep.
I got
How many of you, now that you see the answer, are like, oh? Oops.
Yep.
Go ahead, Michael.
I had it as 8x plus 18y.
Well, that's if you simplified it. Remember, yeah, if they said to simplify it, you're right. 8x plus 18y would have been the correct answer, but they just want you to rewrite it. Yeah, so that's okay. Go ahead,
I
Jensen.
put mine at 4x plus 9y plus 2
4x plus 9y.
plus 2.
So the original problem is 4x plus 9y, and then all of that times 2, so it changes the problem. That's okay.
That's okay.
All right, Braden?
I thought, I was about to make the 4 like 2 times 2 because I thought it didn't have anything in common.
Yes, so you're thinking if they gave you something like this, if they gave you this, look for something in common. But in this case, they gave you the distributive property. All you have to do is rewrite it to look like that. So we're going back and forth. These all equal each other. Sometimes you go from here to here. Sometimes you go from here to here. Vice versa, all back and forth. Just rewriting it. Okay. Second part. This one's actually, listen, this is actually an easier part because there's less of this and more of like thinking that, oh, okay, I remember how to combine like terms. All right, look at 24. Do you guys remember how to simplify?
Yes.
Before you answer that, just look at 24 first and see if you can figure that out.
Do you think you have it? Do we have to do it if you like?
Well, no, don't do any other problems because some we'll skip, some we'll do.
That's not what I.
Show me some work, and if you get it wrong, you got to show me what I did. Yeah. Sorry about that, 15. Okay. How many terms up here? Yes, ma'am? 3 of them. Are they like terms? Are they like, ma'am? All right, so these 2 are like terms, that one's not? All right, it wants me to do what in these problems? Read the instructions. Max? Simplify. I want this to be as simple as it can be. All right, so how can I make this simpler? If these are like terms, how can I combine them together? I I don't know. Smash them together. See what happens. Marissa?
D outside of the 15, so D plus 15.
Okay, you're almost there. But isn't there a number right there? Do you remember that? Kinda.
It doesn't give you a key, so.
Sorry, what was that?
It doesn't give you.
Like the key? She's the only one talking. Sorry?
It doesn't give you a number like the other ones. It doesn't get you related to our
Let me keep going through this, and then you can re-ask that question. So.
The one's not replacing the D, the one's beside.
Why didn't they just put the one beside?
Yeah, I mean, why don't they just do it? But the reason is because any variable written by itself would always have what number next to it?
What?
Because of which property?
The property that I forgot.
Do you guys remember what it is? The identity property.
Where'd 15 go?
Oh, we're not done yet. We're not done. So we have this, right? Is that it? We got this plus that. All right. I think I need to talk to a couple of you. Bella and John, I'll talk to you after class. But here we have this so far. We're not done. What's this added up together? 7. And then what's 7 times D? 7D. Can we combine it with the 15 and get like 22D?
No,
We can't get, why not?
because they're not like.
They're not like terms. You can't combine these anymore. Okay, let me show you the shortcut. You want to see the shortcut?
Yes.
Okay. Look at the original problem. Could you identify the like terms?
Yes.
Right there. This one has a 60, and that one, although it wasn't written, has a 1D. What's 6 plus 1? And don't they keep the same variable? So what's 60 plus 1D? 70. And then the 15 just stays with it because it can't be combined. Now, with variables, let me show you why these two would be 60. All right, this is kind of like my thought process because a lot of people think, why variables? Okay, do I know what D stands for? No, it's a number. You agree? It's this number right here. It's a mystery number. It's called D. How many D's do you have according to 60? How many? 6 of them. 1, 2, 3, 4, 5, 6. You guys agree with that? You have 6 of these D's, whatever they are. I don't know what they are. When you add 1D, you're just adding one of these boxes, aren't you? How many boxes do you have altogether now? 7 of them. Right? 7 of them. Maybe that helps some of you out. Yeah. And then 15 means 15, so we know exactly what 15 is. I don't know what 7D is because I don't know what's in that box. And that sometimes happens. Okay. Try 25. Oh, yes, ma'am?
I felt like simplify meant like get the answer.
Yeah, this is the answer. There's nothing else you can do. Like,
But you don't, like it doesn't tell you what D is.
exactly. Some problems are going to say, this is D. Now simplify. But this one, you don't know what D is. That's as simple as it gets. Do number 25. Simplify it. Number 25. Simplify it. Oh, you have the answer? Okay, just a moment. I'll ask you for the answer, Brandon, but let me make sure everyone else is on a good time. Is that a question, Elizabeth, or you have it? Okay, I'm going to ask Braden. If he doesn't get it, then I'll ask Elizabeth. Okay, so I'll give you some more time. Actually, you know what? Let me come by and check you guys, and then just to see if you guys did it, I'll say yes, you got it, or no, you didn't get it. All right, so 25. All right. Okay, that's right. Try it out. Try something. Are you opposed to that? Is that? Yeah, just don't pick your nose. All right. Close. Yeah, very close. Good. Good. Write that as 3. Sorry, guys. I'll try to go quickly. So close.
I'm confused on what to do after here.
That's okay. You combine these two together. So what's that? Add it together.
What about the
It gets added at the end. It doesn't combine with that other part. Yes. Yes. Close. You're right. 38, then the 8. Yes. Wow. I might not post this. Oh my. Swivl, what's wrong with you?